Hi guys, this is Reshma. And guys, to to prove this equation, we need to start by differentiating, right? We need to start by differentiating y. So let's do that. Y is equal to p e to the power ax plus q e to the power bx, right? Good. So now differentiating both sides with respect to x, we have dy by dx. P is a constant, and the differentiation of e to the power, let any constant be there, guys. If a constant is there, suppose a is the constant, then if you differentiate it, then what do we get? We'll get a the constant into ax, right? So it will be p into a into ax, right? Plus q. Similarly, when we differentiate, it will be b into e to the power bx. It is b. Okay, so now what we'll do, this is our dy by dx. So continuing further, we'll find the second differential, differentiating both sides again. Okay, let me write it like this. Sorry, dy by dx. It is, guys, first term when we differentiate, it is p a to the power ax, right? Dx. We did the similar thing in the when we were differentiating y for the first time also, guys. We were differentiating each term, okay, because we both the terms are added, right? So when we have addition, we can differentiate them individually. That is one of the properties. So square p a, and again the differentiation will be a into ax, right, of e to the power ax, plus q into b, that is our constant, and the okay, guys, here I wrote it is b in here. Okay, I wrote by mistake. So the differentiation of e to the power bx is b into e to the power bx, right? Good. So this becomes p a square. Let me write it properly. P a square e to the power ax plus q p square e to the power bx. So now it's time that we prove our given equation. So guys, this was our equation, right? Now what we'll do, we'll substitute the value of dy square by dx square into the given equation. What was the value? It was p a square e to the power ax, the first term, q into p to the power b square, minus, and now we'll substitute the value of dy by dx. What was that? p a e to the power ax plus ab, the value of y as given in the question. Okay guys, so this is an arrow mark. Okay, so the next step, let's see, bx plus q b square bx minus. Okay, first what we'll do, guys, what we'll do, a. So guys, this will be, what we are doing here is that we are opening the bracket, right? First we are selecting a, right, and then we are selecting b. So I'm sorry, it is p a e to the power ax plus q b e to the power ax, right, plus plus AB P E AX plus Q EBX. Okay, the next step. Now next step, let's open all the brackets. Guys, in this step, I will be repeating again. In this step, we just have broken down this whole state. Okay, this whole terms here. I just did that to make things clear. I guess it helped. So anyways, so let's continue. PA is okay. PA square EX plus QP square EPX minus PA square EX minus QAB EBX. Right, guys? Let's check the steps. We are first multiplying it to the first term and then to the next term. Okay, and now we will do the same thing. We'll multiply first to the first term, b to the first term. That will give us PAB e to the power ax, and when we multiply it to the next term, guys, it will be QB square this is b bx plus AB, P is there, right? We'll write P first because in all statement I have written P first, right? It will just make things clear. That's all. We can write P next also, that won't be a problem. Bx. Okay, cool. So now, guys, let's see the terms. PA square, the first term, and this term, they are plus minus, right? We can cancel them. Okay, so next term is QB square, and here. Okay, similarly, guys, this two term got cancelled, right? Similarly, you can see the remaining two terms can also be cancelled. I'll just use different color for them. PB square here and PB square here, and this one and this one. Okay, if you don't mind, I will just use green also over it so that it's more identifiable. Okay, so as you can see, this all sums up to 0. Thus proved. Thank you.